Hi, sixth graders. Today we're going to take a look at lesson 9. It is on page 95 of your textbook. And our target goals are that you'll be able to relate decimals to mixed numbers and round add-ins, minuends, and subtrahends to whole numbers in order to predict reasonable answers. You'll also be able to use your knowledge of adding and subtracting multi-digit numbers to find the sums and differences of decimals. And you'll be able to understand the importance of place value and solve problems in real-world context. Now, I would like you on page 95, off to the right-hand side, I'd like you to copy down these vocab words so that you know what we're talking about. Okay, so in an addition equation, the two numbers that we're adding are called add-ins. And you'll see those right here, okay? So we have our 25, actually I shouldn't have circled some, our 25 and our 15 and our 11 are add-ins. The answer to our addition problem is our sum. In a subtraction equation though, the number that we are starting with is called our minuend, and what we take away from it is our subtrahend, or what we subtract from it. And then our answer to it is the difference. Okay, so those are some of those vocabulary words that you're going to see, and you might need to refer back to those. All right, so let's take a look on page 95 on number 1. Okay, looking at number 1, let's go ahead and do this two different ways. Okay, so I'm going to first do this. It's an addition, so we would always set it up vertically. 376, and I always start, I myself, with the larger coefficient up front. So I'm going to start with 376 and 77 over 100. And then we have 25 and 3/10. Now I need to get my denominators the same in order to add. So what I'm going to do is I'm going to rewrite my 100 over here, and it didn't change, but I know that 10 can go into that 100, so I'm going to change this bottom mixed number to having a denominator of 100. So 10 times what gave me 100? Well, 10 times 10. So 3 times 10 is my new top number. 3 times 10 is 30. Then I can just go ahead and add. 77 plus 30 is 107, and my denominator doesn't change. Then I'm going to add like normal. 6 and 1 is 11, or 6 and 5 is 11. 7 plus 2 is 9, plus 1 more is 10. Write my 0 down, carry my 1. And 3 plus 1 is 4. But the problem is this says 401 and 107 over 100. Well, this right here is improper. So we need to fix that. We need to change that to a mixed number. So I do that by saying, how many times does 100 go into 107? Well, it goes in there one time. But how many would be left over? Would just be a 7. And our denominator stays the same. I'm not going to use that one. So now I have to add 401 plus the 1 and 700ths. So I should get 402 and 7 100ths. That would be my final answer. Now, doing it a different way, I'm going to go ahead and show you, some of you would rather work with decimals instead of working with fractions. So another way you could have done that was write this number as decimals and then just add them. So I'm going to write 376 and then I have my tenths, hundredths. There's my tenth spot, hundred spot. So I could put my 77 here because I have 77 hundredths. Plus I have 25 and 3 tenths. Well, here's the tenths, and I have 3 of them. So then I could add right here. When I add, I get 7, 7 and 3 is 10, so I put my 0 and carry. 6 and 6 is 12, carry. 7, 8, 9, 10, carry. 3 and 1 is 4, and my decimal comes straight down. So my answer here is 402 7/100. These are equivalent. They're the same thing. So we can do it either way. Now, most of the time, they're going to want you, if they gave it to you in a mixed number, they're going to want this mixed number answer. So if you did it decimal-wise, you could then just change that to 402. That's the first part. And then read this, tenths, hundredths, and there's 7 in the hundred spot. So that would be the same thing. Okay, so you could do it either way. Let's go ahead and look at example 2. Now, example 2 is a little bit different in the fact that you don't get to choose which number is going to be the minuend and which one is going to be the subtrahend. You have to write it in the way that they say. So as I go to do this, we can do 426 and 1/5. That has to be the minuend. It has to be on top because we started with that. Then we're taking away the 275 and a half. Now, we can't subtract these without common denominator, so we have to get it. Let's go ahead and get our common denominator. 5 times what gave me 10? Good, 2. So 1 times 2 is 2. And 10 here, so how do we get from 2 to 10? Yep, we multiply by 5, and 1 times 5 is 5. So now we're going to go ahead and subtract. Can I take 2/10 minus 5/10? I can't, right? So I have to go next door and borrow. I'm borrowing from this 426. So if I borrow one from 426, I really now have 425 because I borrowed one. But when I borrowed one, we have to add these two numbers together. And the reason we're adding those is because we're talking about objects that have 10 pieces. So if I went and borrowed a pie and it had 10 pieces, when I came back, I already had 2 pieces and I borrowed the one that had 10, so now I have 12 pieces. So that's a little bit different. So 12/10 take away 5/10 is 7/10, and then I subtract the rest like normal. 5 take away 5 is 0. 2 take away 7, can't do, I have to go borrow and make this a 3. This becomes a 12. 12 minus 7 is 5, and 3 minus 2 is 1. So my answer would be 150 7/10. Now, I could also change those a little bit, and if they were smaller numbers, you could do around the horn, and then subtract. In this case, the numbers are not even the same on the denominator. Would be a total waste to do it that way because it would be a whole lot of work and a whole lot of big numbers. But we did it. Okay, let's go ahead and look at number. Let me find my next one. Was that 3? Oh, there we go. All right. Let's look at page 96. On 96, we're looking at exercise 1. And it says, Samantha and her friends are going on a road trip that is 245 7/50 mile long. They've already driven 128 53/100. How much farther do they have to drive? Okay, well, let's take a look at this. If we have this whole trip that they have to go on, okay, and the whole thing from start to finish, they said, was 245 and 7/50. Oops. And they've already driven part of it. Okay, so they've driven some. So I'm just going to mark off, even though I don't know exactly how much, but they drove already 128 and 53/100. And the question is, how much do they have left? What kind of a problem is that? Good, it's a subtraction problem because we want to take the whole thing minus what we've already done. So we need to start with our whole thing, which is our minuend, 245 and 7/50, and subtract 128 and 53/100. And if we're going to go ahead and do this, we need common denominators, right? So let's change this to 100 because I can see that 50 goes into 100. How do I get from 50 to 100? Yes, times 2. So 7 times 2 is 14. Now the second one, I don't even have to change because it is already over 100, so I can leave it. And can I take 14/100 minus 53/100? No, I can't. So I have to go borrow. The 5 becomes a 4. And when I went and borrowed, remember what I have to do in fractions. Good. I have to add these two things together. So my new number is 114. So now I can subtract the 4 minus 3 because I'm really doing this problem. Okay, is a 1, and 11 minus 5 is 6. So I have 61 over 100. And then 4 minus 8, I have to go borrow. 14 minus 8 is a 6. 3 minus 2 is a 1. 2 minus 1 is a 1. Now, if I would have done this way back here, instead of writing it as a fraction, I could also have written 245, and we said it was and 14/100. That was my original, okay, 14/100. And take away 128 and 53/100. That would just be a regular subtraction problem. I would have gotten the same thing. And then I would also like to show you that we can estimate to see if our answer sounds right. So if we look at this 245 and 7/50, it's about how many miles? Yeah, 245. And 128 and 53/100 is about how much? Nope, not 128. Do you see how this 53 is more than halfway to 100? We have to round it up. So that is going to be 129. And when we subtract this, we would get 116, which is very close to the answers we already got. Okay, so you need to be able to say, oh, that's way off, or oh, I did a really good job on that. You need to be able to see if you're close. Okay, let's look at number 2. Number 2 says Ben needs to replace two sides of his fence. One side is 367 and 900 meters long, and the other is 329 and 3/10 meters long. How much fence does Ben need? Well, let's estimate first, okay? So let's look at 367 and 900. Is 9 close to halfway? No. So we're going to ignore, sorry. So we're going to ignore that part of that fraction. I have a feeling it's going to do it again as soon as I touch. Nope, there. So we're going to ignore that little fraction, and this is going to be just 367. And 3/10, that's 3 is not half of it, so that's going to stay at a 329. And if I'm replacing them, I need both of them. So I'm going to have to add them together. So I'm going to get 16, 6 and 2 is 8, plus 1 is 9, and 3 and 3 is 6. So we're going to get about 696 meters. All right, let's go ahead and do it for real. Let's see what we get. 367, and because I see 110 right there, I know that those are easy as decimals. So I'm going to do mine as a decimal. I need tenths, hundredths. So I need it in my spot for hundredths, and I have 9 of them. So what am I going to have to put right here? Good, a 0, right? We need a filler. And then I'm going to have 329, and this time I have 3 tenths, and here's my tenth spot. So I just have to put a 3 in there. Then I can add 9 plus nothing is 9. Nothing plus 3 is 3. Decimal straight down. 9 and 7 is 16, and I carry. 6 plus 2 plus 1 is 9. And 3 plus 3 is 6. So 696 and 39 hundredths meters is what he'll need. All right, we're good. Let's go ahead and stop, and I'll see you tomorrow.